Good morning. My name's Mike Mermuys. I'm the Vice President of Shaler. Also speaking as Clayton Parks and Teemu Oska today. Shaler's been around since 1904. We've been incorporated, or our first patents really started in 1899. We've been a solution-based company, so anything that we see problems in the industry, we go ahead and try to find out a solution for them. One of our first innovations was called the vulcanizer, and basically what it was an apparatus for tubes back in the early 1900s. So if you sprung a leak in your tube of your tire, you would take it off right on the road, and this product could fix your tube, put a patch on it, and then be on your way. Some of the other innovations from then on, we've done things for nuclear submarines, industrial applications, locomotives, and finally, over the years, the ice rink industry. Some of the industry challenges that we all face today is most rinks, I think all rinks have some sort of leaks. And if you have a leak, you're going to be losing money. Risk management concerns, increased liabilities, and also environmental impact. And as everybody knows, rising energy costs, not only by year-to-year increases, but also with your system not running where it should be. Poor ice quality, ice surf staining, arena downtime, environmental liability, and rising energy costs, as I mentioned earlier, due to your system not performing the way it should be. These are some of the leaks that I think everybody has seen at one time or another. On the top left over here that's more of a brine leak. This is a rink that we've done out of Finland. The top right-hand corner, that is, you can actually see the lines in the rink, and actually that's glycols. It has a little bit of a orange-reddish tint to it. And this is a rink that we did in the Michigan area on the top left and the top right. This is a rink built in the 1970s, early 1970s. And it actually had, as you can see on the left here, you could actually see the piping coming through the floor and actually see the leak actually coming up through the floor. And we solved those leaks. Okay, what causes leaks? Sooner or later, every rink's going to have some sort of leak. Frost heaving fatigue is a lot of it. And I think some of the biggest things that we hear from contractors when they're into this is the stress and tube vibration. So when these tubes are encapsulated in the concrete, believe it or not, they actually vibrate just very slightly. Then over time, they're rubbing on the concrete, and they start forming little pinholes over time. So that's a big cause of it. Expansion contraction cycles, especially in the northern side, northern parts of the country. You have a lot of that. pH levels being off, and improper corrosion inhibitors. Environmental liabilities. This is a big growing aspect. Coolant leaks create other problems. Structural damage, soil contamination, groundwater contamination. We just had a rink in our local area. They've had, actually where I play at, they have had small leaks over the last 5 to 6 years that became larger leaks. And what they actually had is a big transfer line that would go from one of the rinks. It was a 2-pad facility. It went from one rink to the other. And in the wintertime, they had noticed that they'd start losing more coolant. And what happened this winter, it was so cold out, that 6-inch transfer line actually broke because the glycol, it was actually a glycol rink, and the glycol over time just lost its cooling or freeze protection, and it snapped that 6-inch transfer line. Before they knew it, before they could shut it down, they lost 3,000 gallons of glycol. So that 3,000 gallons of glycol ended up in the sewer system. Next thing you know, the city's coming over and saying what happened, and they're telling them, and then the EPA got involved. Now, things happen, so I mean, there's fines and things for that. What they're kind of having a hard time explaining is why they've been putting 3 55-gallon drums of glycol for the last 6 years into their system. So that's the problem that they're running into. It's not that you had the accident, but it's when they start going through your records that, well, yeah, you've been adding these drums of glycol this time. Where was that going? So they knew that where it was going, they just didn't have a chance, an opportunity to have it fixed. Risk management and liability issues. I'm not sure if you guys read about this recently. A gentleman came to drop-in hockey. He was skating around in warm-ups and went through a soft spot in the ice and fell, broke his leg, and decided to sue the ice rink. His initial lawsuit was for $1 million, saying that the rink had leaks and they weren't properly maintaining their ice. And what it came down to, reading through the article, was they settled for $90,000. How bad that sounds, but that's what we're all facing. Energy savings. One thing that this product does is increases heat transfer. We'll get into that later. The biggest thing it's going to do, it improves your system performance by keeping it to where it was when it was new. Okay? And that means proper fluid levels, and also making sure you're not getting any type of air in the system that creates a harder environment to cool your ice. Okay, when you discover a leak, like we talked about, you have two choices, either ignoring it or fixing it. And Teemu's Oska is going to come up and start talking about some of the products that we do have.
All right, so we have three main products that we're here to talk about today. The very first we have the cooling application, which is for the secondary refrigeration system on your cold floors. It's a product to fix leaks. It not only fixes the leak, it actually has a cleaning effect that helps clean the inside diameter of your pipe, which means all that rust scale slime buildup that it's on your system, on the secondary refrigeration system, the product will help to clean that to make it more energy efficient. The third main function on the product is the heat transfer enhancement. The product will enhance the heat transfer on the system, and Clay's going to be walking through all those details with the kind of the how the product works section. So you'll be hearing more details on the product. The heating application, it's for the subfloor systems. So your subfloor heating system, everybody knows how difficult leaks are on those systems, and especially how hard it is to fix. The great thing about the product is that it's a very simple application to fix any of these subfloor leak issues that you might have on the system. The third main product that we're here to talk about is the preventive maintenance product. The maintenance product, it's a great product to prevent the leaks on the system. What that product does, it gives you a 12-month protection on your system against the leaks. And not only, it provides the leak prevention, but it actually has all those other great functions, as I mentioned, the energy efficiency, the cleaning effect. So you're attacking the leaks immediately when they occur on your system. So you have no downtime on the operational side. Your glycol or primer, your normal coolant is always infused with our product. So the leaks are being taken care of immediately when they happen. And those are kind of the main three components and the functionalities of the product that we always talk about. Here's a little bit more about it. It improves system performance before the leaks become an expensive problem, as I mentioned on the preventive maintenance product. Stops leak before you ever lose coolant. As I mentioned, it prevents on the operational side, not worry about having those downtimes, because you have issues on your subfloor or your main cold floor.
Good morning. Oh, there we go. I'm Clay Parks. I work for Shaler. They usually keep me locked up in the lab, but glad to be out here and talking to all of you. Explain a little bit about how the product works, which is one of the most commonly asked questions that we do receive. There's a couple benefits to the product beyond just sealing leaks or preventing leaks from happening. One being pump seal lubricant. Some of the material is very, very fine, and it works like graphite to penetrate between the shaft and seal to keep that seal lubricated and also to keep the seal facing clean. One of the other benefits certainly is the stop leak. What we have here is just a simulation of the tubing underneath the ice, and product actually circulates through. If you have a crack or a pinhole, it'll penetrate that hole and dry, and it expands about 15% to be able to seal the leak. So that's how the product actually works. There's a couple other benefits, as was mentioned by Mike and Teemu, is it helps control the pH, so it keeps rust and scale buildup from happening. And also, if you do have some rust and scale buildup, what it can do is it will circulate through the system, scrub and buff, and gradually clean those pipes and keep those cleans. And that's one of the ways that it actually aids in heat transfer, also as simulated here. Heat transfer. This is one of our biggest assets as far as the preventive maintenance of our material. Because of the surface area of the product inside, what it does is it aids on both the chiller loop and underneath the ice to aid in heat transfer on both ends. And what we've found is typical results are about 2.5%. But you can, with some of the other benefits of the product, you actually can see higher numbers than that. What we do with this type of product, too, some of the things that I do in my lab are simulating leaks. So we can see how it's going to work in different materials. We actually work with different OEMs to develop products specific for different industries, as was mentioned over the years, from the nuclear submarines to pretty much anything you think of, even locomotive engines. We've pretty much been able to figure out a solution for all of those. But this particular case, there is an industry standard ASTM, the D3147, for stop leak materials. And running this, you're wanting to make sure that A, you can seal a leak, but B, that you're not going to cause any unintended consequences inside the system. So you make sure that the product's going to be able to do that. What we've formulated with the RINKSEAL Pro is we're able to seal up a 0.64 millimeter round hole and a 0.25 millimeter slot or crack in the system. Also, going on those unintended consequences is the ASTM D1384, which goes through corrosion on all different types of materials. So looking at what could be in any, come in contact with the product in any type of industrial application, like your copper, brass, steel, cast iron, aluminum. So we cover the testing to make sure that it's not going to affect the corrosion inhibitors that are in the whatever coolant that you're actually using. Case study that we did happens to be a rink in Flint, Michigan, and they mainly came to us because they actually had a leak. It was an older rink with the first ice being put in 1972, or the first sheet. They have 3 sheets now. They had a pretty aggressive initial leak. We were able to seal up and take care of all of their leaking issues. And in fact, when this case study was done, it was 13 months after the initial product was put in. At that point, no further glycol had to be added actually to that system. But the big bonus, when we went and looked back at their savings in electrical bills, to drill down, just highlight here, we looked at previous year's bills before they put the product in, after they put the product in, combined that with usage of the rinks, also looked at outside weather, trying to take all factors in. And even with increased usage of the ice, they actually dropped electrical bill usage 6.9%, which is pretty impressive. This was for multiple reasons. Was one, because the product was in the system to aid in heat transfer. Another is keeping that system clean so it's working efficiently. And then the big one, too, is that there was no air in the system. It was topped off with glycol as it was supposed to be from the original.
The reason you come to these things is because anytime you put a group of ice makers together, it's a good day. It's about trading information. Everybody's got ideas. I come here to steal all the really good ones.